Around a year ago, I went to this island in Bar Harbor, Maine, that's only accessible by a land bridge exposed twice a day during the low tides, which left me with a lingering question. Why do tides even exist? You might already know that the Earth's gravity pulls on the moon, but the moon's gravity also pulls on the Earth. This gravitational force is super weak. It can't pull water directly off the planet, but it is strong enough to move water along the Earth's surface to the spot that's closest to the moon, which raises the water level, and this is called a tidal bulge. As the Earth rotates daily, coastal locations pass through the tidal bulge once, experiencing high tide when closer and low tide when further away. This explains one tidal cycle per day, but in reality there's two cycles and another tidal bulge on the opposite side of the planet. There's nothing actually here to pull water towards this side, so why does this tidal bulge exist? Let's think of our planet as three different parts, the solid Earth in the center with two oceans on both sides. Looking at the equation for gravitational force, we'll see that it decreases with greater distance, so the moon pulls the hardest on the near ocean, less on the Earth itself, and weakest on the far ocean. From our perspective on Earth, it looks like water is being pulled off the surface on both sides of the planet, but on the far side, the water isn't moving away from us, we're actually leaving our ocean behind. You now understand the idea of differential gravity, which causes the uneven pulling known as tidal forces, and tidal forces are present all throughout the universe. For example, the Earth's gravity is much stronger than the moon's due to its higher mass, so its tidal forces are strong enough to stretch the moon's shape into an ellipse rather than a sphere. And scientists believe that Saturn's rings are also caused by tidal forces, which can not only distort a moon's shape, but rip it apart entirely from so far away that the pieces can stably orbit the planet. So the next time you're sitting on the beach, watching the tide roll in, you'll know enough about tidal forces to be thankful that you're experiencing one of the more pleasant ones.